first glance, this seems like an ordinary paint job, but the real challenge is dealing with the immense weight. For a massive Airbus A380, technicians must spray nearly 1,000 gallons of specialized paint. To save weight, they apply a white base coat that reduces heat and fuel consumption. Protective templates then mask the fuselage before the vibrant livery is added, which is eventually peeled away to reveal a perfectly aerodynamic finish. At first, this seems like pure brute force, bending solid steel, but what you're seeing is the critical moment a massive ship anchor chain is forged. Instead of casting the metal, giant hydraulic rollers precisely loop these white-hot alloy bars through the previous link. This overlapping technique is what prevents structural weak points. The real secret happens during the flash butt welding process, where extreme electrical currents fuse the joints instantly, creating a bond capable of holding a literal megaship against raging ocean currents. At first, this looks like a basic manual sorting process, but it's actually a vital ultrasonic cleaning and strict quality control checkpoint for stainless steel forks. Every single fork is meticulously hand-inspected for microscopic surface flaws, ensuring a flawless mirror finish before packaging.
That's architecture, not a bun.
Not one hair out of place.
This process looks chaotic, but it's carefully controlled. What you're seeing is the critical preservation of massive ship anchor chains. They are first submerged into a deep pit of protective bitumen tar to seal the raw alloy steel. Once coated, technicians apply a heavy layer of marine-grade white paint. This stark white finish isn't just for visibility, it serves as a crucial indicator, allowing ship crews to instantly spot microscopic stress cracks and structural wear before a catastrophic failure occurs at sea. What you're seeing is a high-speed CNC lathe, precisely carving a heavy steel bearing sleeve. Instead of manual cutting, a specialized diamond tool slices through raw metal like butter, utilizing optimized rotation speeds to ensure microscopic precision and prevent friction overheating. At first, this looks like chaotic metal hammering, but you're watching the ancient art of forging a traditional Japanese katana. Master bladesmiths repeatedly fold white-hot Tamahagane steel over itself to eliminate impurities. This intricate layering process creates thousands of micro layers, giving the sword its legendary strength and distinctive grain structure. Most viewers miss what's happening in this moment, but you're actually watching the production of wooden pencils. Specialized grooving machines carve precision slots into solid cedar slats. Instead of inserting single graphite leads, automated arms perfectly place multiple leads into these aligned tracks, preparing them for a sandwich-like bonding process. This process looks surprisingly clever. What you're seeing is the plastic injection molding process, forming durable measuring cups. Liquid polymer is forced into ultra-polished steel molds under immense pressure, instantly cooling to produce crisp, high-precision measurement markings. At first glance, this process looks ordinary, but it's carefully controlled. What you're seeing is high-speed automated bookbinding. Specialized machinery collates separate stacks of paper into perfect chronological order, utilizing air suction, and precise timing mechanisms to prevent jams and guarantee structural alignment. What you're seeing is actually surprisingly clever. Technicians are precision-fitting modular passenger seats inside a commercial aircraft cabin. Instead of complex welding, the entire seating assembly locks instantly into heavy-duty floor tracks, ensuring rapid installation and maximum structural safety during turbulence. That movement isn't random at all. What you're seeing is an automated lock-forming machine precisely shaping galvanized steel sheet metal into ventilation ducts. Instead of complex welding, it uses heavy rollers to fold the metal edges into tight, interlocking seams, ensuring airtight structural joints for high-efficiency airflow systems. At first, this seems like pure brute force, flattening raw metal. But what you're seeing is a high-tonnage industrial stamping press, forming precision automotive body panels. Instead of slow cutting, the heavy die strikes with hundreds of tons of pressure, instantly forcing the sheet metal to take shape while maintaining uniform material thickness and perfect structural integrity. What you're seeing is actually surprisingly clever. Automated systems are precision assembling high-capacity power banks. High-speed robotic arms seamlessly position lithium-ion battery cells into sleek protective casings, utilizing custom ultrasonic welding to fuse the internal circuits instantly and guarantee stable, efficient energy distribution. Most viewers miss what's happening in this moment, but you're watching the automated precision binding of paper notebooks. Instead of using fragile glue, a synchronized mechanical jaw forces durable metal wire spirals perfectly through pre-punched holes, instantly locking the pages to guarantee effortless, flat-lay page turning.